Spinning up a Kubernetes cluster for each application team per environment gets expensive very fast. Today, I want to talk to you about vClusters from Loft Labs and see how we can build an internal developer platform and use vClusters as vending machines for easy and quick creation of Kubernetes clusters. It's quite a fascinating technology, and I personally use vClusters on a daily basis. Give me an hour of your time, and I will teach you how to build an IDP with Backstage, Crossplane, GitHub Actions, ArgoCD, AWS, and vCluster. Ready to learn? Let's get started. So what is vCluster? On the left-hand side, you can see that we got three separate clusters. So this is without vCluster, cluster 1, 2, and 3. And we have some tenant workloads, a cert manager, OPA, Istio, HashiCorp Vault, for example. And on the right-hand side, we have one single cluster, and it's called the multitenant cluster. And in here, we have the same cert manager, OPA, Istio, Vault, maybe Datadog, other workloads. And then we've got separate tenant workloads in their own virtual clusters. So vCluster, virtual cluster. So here we're able to use one big host cluster and then separate isolated virtual clusters. How does that help? vClusters are like a lightweight namespace. They're isolated like separate clusters, and they're very fast to launch like containers. So why vClusters? As you can tell, the number one reason is reducing Kubernetes costs. And not only that, it spins up Kubernetes clusters very quickly. You can spin up to hundreds of clusters in seconds for a fraction of the cost that you would otherwise if you were to use real host clusters. Not only that, I also like it because you can quickly experiment with things. So you can create a virtual cluster, brand new cluster. You can add CRDs, all kinds of things, and you don't have to worry about cleanup. You can quickly delete that virtual cluster and you're good to go. You didn't mess up anything in your host cluster. What are we going to build in this demo? First off, we're going to build our host cluster, and this one is going to be hosted in AWS, so it's an EKS cluster. And to do that, I'm going to take a platform engineering or an IDP kind of internal developer platform kind of approach with Backstage as my front end, and I have a template. So we fill out the template form in the template, and that will go ahead and launch a GitHub action pipeline, which in turn is going to create an ArgoCD app. And this ArgoCD app is actually going to call on Crossplane, and Crossplane is an infrastructure as code tool. And Crossplane is going to go ahead and build our VPC in AWS with subnets, with routing, with IAM rules, node groups, EKS, an EKS cluster with node groups, and so on. Everything we need to do to get our EKS cluster running. So that's the first stage, right? This is where you're going to do this once. Maybe you have 2 or 3 host clusters, one in EKS, maybe one in AKS, one in GKE, right? One in each one of the major hyperscalers. And once you have that, then we're going to start building vClusters, right? This is where now we've moved from the platform engineering persona now to a developer or an application team persona. And what's going to happen here is we're going to use the same workflow. Backstage is our front end with a template for creating virtual clusters. And when you launch the template, GitHub Actions again is triggered and is going to call on ArgoCD. It's going to create an app in ArgoCD. And this time, this application really is the vCluster, the virtual cluster. And we already have our EKS cluster ready to go from the previous step. So it's not generating any EKS cluster in this case. We're creating vClusters inside of our host EKS cluster. You can see vCluster 1, vCluster 2. So really every application team can get their own vCluster. One could be for development, one could be for QA, test, and so on. So you don't have to just have one vCluster per team. And then from here, the way we're going to deliver the kube config to our users, our developers, is through Achilles. Achilles is a secrets management tool. And we're going to send that kube config over to Achilles in a certain location. And then you can just grab the kube config and then you'll have access to the cluster. And then finally, we get feedback from ArgoCD straight into Backstage when our cluster or our virtual cluster is ready. And we're good to go. Your developers now have a virtual cluster in your EKS cluster. Again, you don't have to worry about spinning up additional EKS clusters. It's all done via vClusters. And with that, we're going to jump into our demo and see all of this in action. Here's our GitHub repo. And what I recommend here is to fork this, because when you fork it, you'll have control over the repo when it comes to using ArgoCD and so on. So let's go ahead and fork this. I can use everything the same. Let's create a fork. And once we create a fork, we're actually going to use GitHub Codespaces. If you go to code and then create Codespace on master, this allows us to have pre-built configuration. So you don't have to mess around with your own computer, installing different tools and so on. I already have kubectl installed in this Codespace and a few other things. If you follow any of my tutorials, you see that I usually do that, so that saves a lot of time. If you go under dev container, you can see some of the things that it's going to do. Just if you're curious, you'll see that there's a post create command that runs this startup script. And this startup script has a few things we can take a look at. You can see it's installing kubectx, which is my favorite way to switch context, and also kubeNS to quickly switch namespaces. And K9s is also going to get installed. So K9s for visibility and observability of our Kubernetes cluster, and some aliases to make my life easier and maybe your life easier as well. And then we have ngrok. We're going to see that ArgoCD also, and vCluster also will get installed for us. Okay, following instructions here in the README file. So you're going to see that we're going to need a Kubernetes cluster. And if you're subscribed to the premium tier in Tech and 8 Academy, you'll be able to get a free Kubernetes cluster, which actually, fun fact, uses vCluster under the hood. So we're going to need that, and we're going to need access to AWS. So you can continue to follow along with this guide if you have your own AWS account and also your own Kubernetes cluster. It could be a Docker desktop, for example. That's fine. But if you are a subscriber to Tech and 8 Premium, you can go ahead inside the Platform Engineering Playground and then supply your email address. And there we go. The request is sent. In just a couple minutes, we should get an email with our new Kubernetes cluster. So while this happens, let's go ahead and create an AWS environment as well. So supply the same email, launch the AWS environment, and this will give us also an AWS environment that's valid for 3 hours. The Kubernetes one is valid for 6 hours. So that should be plenty of time for us to get through our demo. So we get the credentials here. We do get it in the email as well. So we're now pretty much set to go. I just copied the information from the 2 emails here in a notepad so we can easily access it. And the first thing is we need to access this cluster, this new Kubernetes cluster. So we're going to copy this kube config. And from here, I can run quickly kubectl get nodes. And I can see I'm already in a cluster. So that's great. Let's clear out of here. And the second one we are going to use at a later time. We can see here what we need, the access key ID and access key for AWS. So we'll leave that for now. Okay, perfect. Now we can run the install script, shell script right here, and this should go ahead and install a few things for us. You can see it's creating an ArgoCD namespace. And if we take a look here at the script, you can see it's installing ArgoCD, it's installing Crossplane, and installing some provider configs, and also XRDs and compositions for Crossplane. And finally, it's going to get Backstage ready for us, and we should be good to go. So it should take maybe a minute or so, and we should be able to continue on with our demo. The script has completed successfully. We can continue. I can see that I have ArgoCD, Backstage, and Crossplane systems. So this is great. And if we go ahead and log into the ArgoCD UI, what we need first is to get the actual initial admin password. So run this command, and this should give us the password. There we go. Here's our password. But first, let's go ahead and port forward. Actually, let me use this tab. Port forward, ArgoCD, service, ArgoCD, server. I'll use port 8080. Okay, we ran into a port forwarding issue, and I've run into this before with GitHub Codespaces. So the best thing to do is to open this in your own VS Code desktop. So if you run that and go ahead and open it in Visual Studio Code, actually that's much nicer. And what you'll see is that everything we've done remains the same. The difference is that now we're running locally on our computer and we're SSHing or connecting into the remote repository. We'll just give it a minute or two for it to connect to that GitHub Codespace remote repository. Okay, so our Visual Studio Code window opened here, and as you can see at the bottom, we are in Codespaces, so that's excellent. And what we can do now is once again go to our terminal and run kubectl get namespace just to make sure we're all good, and that's perfect. Let's bring up our README file once again. Okay, we're all set to go. Let's now forward over our ArgoCD port so we can first of all get our secret, which we just got, and then let's forward the port. This allows us to access on our own local machine ArgoCD. So let's go ahead and copy our password right here. And now we can open this in a browser and we can log in. Admin and the password we just copied. And there we go. ArgoCD is ready to go. Let's go back now to our Visual Studio Code and continue on with our guide. So we're all ready to go. We can also log in via the CLI, which is going to be important. So let's open a new tab and run this. And while this logs in, we need to run ngrok. And the reason for that is we're going to need to have GitHub connect to our ArgoCD. So remember, ArgoCD is running internally. Now in production, you're going to have an ArgoCD instance that has its own hostname and DNS, and everything should be fine. And you won't need ngrok, but just for the demo purposes, we're going to need to run ngrok. And if you don't have ngrok, go ahead and sign up here. It's really useful when you're doing some testing webhooks, testing all kinds of things locally. So go create a free account, and we're going to need a token here. So I'm going to run this, and I'll be back in just a minute once we have our ngrok running. Okay, I'm back. I just didn't want you to see my ngrok token, but now that I'm all signed in, I can go ahead and run this command, and this is going to forward any connection on port 8080 to this particular URL, which I can see if I can make you see it better here. This one here. Something like that. You can see here, this URL, which ngrok gives us for free, is forwarding ports to HTTPS on local port 8080 for our ArgoCD access. Okay. So let's continue, and let's open a new tab again. We're going to need an ArgoCD token for our Backstage plugin to allow Backstage to interact with ArgoCD. We will need that, especially since we want to get some feedback once we run the template, and want to make sure that once the vCluster is created, that it comes back to us and gives us an idea that it's ready, the vCluster is ready. So we're going to run this command. It's a patch command to allow admin to issue API keys. And now we can generate this token here using this Argo command. Okay, so here's our token. Let's copy this into our notepad file, because we're going to need this later. So ArgoCD token. We can now take a look at the workflow here for deploying a Kubernetes cluster. This is going to be our base host EKS cluster. And there are a bunch of things here. We're going to install the ArgoCD CLI into the runner, the pipeline runner in GitHub. We're going to log into the ArgoCD server using some credentials. As I mentioned, we're going to put some secrets in GitHub Actions. So we're going to access the ArgoCD server. We're going to add the repository that will be monitored by ArgoCD. And then using the ArgoCD CLI, we're going to create a new application for the cluster pointing to the repository path that contains the cluster manifest. And this will make ArgoCD deploy and then sync the cluster for us. Okay, we're going to need some secrets to put in here. But if we want to quickly take a look at the pipeline, just to show you what a GitHub Actions pipeline looks like if you haven't seen one before, you can see that this is on workflow dispatch. The reason for that is Backstage is going to start this pipeline. And I have a bunch of inputs here that are going to be provided to me by Backstage. So Backstage, as you're filling out the template in Backstage, is going to send the variables here, this cluster name, repo URL for Argo, and a bunch of others, depending on if you're using GKE or EKS. We're going to use EKS in this demo. And then the job here, we're deploying the cluster, and you can see, first of all, we're installing the ArgoCD CLI, logging into ArgoCD, and here's where we need the ArgoCD server, the user, the password, and then registering the repository in ArgoCD. And once again, we're using the My GitHub token here to be able to register the particular repo we're going to use in GitHub with ArgoCD. And then we're going to deploy the cluster with ArgoCD. And this is really what's going to kickstart our Crossplane to create the EKS cluster. Now let's talk a little bit about the secrets that we're going to need for all of this to work. So I have here a picture for us, and we'll see right in GitHub Actions where to put this. But basically the secrets are Achilles credentials, and reminder, Achilles is going to be used to store the kube config of our vClusters at the very end. So we're going to need those. ArgoCD password, the one we just saw before, and again, you can use this command to get it. The ArgoCD server, that's the ngrok server URL, which is this one that we just saw. And then the AWS access key ID and secret and access key, which we got from before. I'm using Cloudflare. Cloudflare is used for DNS, and I'm adding the Cloudflare API token and zone ID to allow me to create DNS records on the fly when I'm creating the vCluster. And that way you can access, or my developers can access, the vCluster remotely. And they don't have to have any kind of access to the underlying host EKS cluster. Then my GitHub token, which is a GitHub token that we're going to use to access GitHub. And then a target domain, and this is the host name for the load balancer that Traffic's ingress route TCP is going to use for the vClusters. More on this later. We don't need it right now. Just know that we're going to need this to be able to access the vClusters at the very end, which is basically the load balancer that EKS is going to create for us. In terms of scope for the GitHub token, this is what we're going to need. We're going to need repo access. We're going to need workflow access, writing packages, deleting packages, read the org, and read a public key, and delete repo. This is the scope that we're going to need for the GitHub access token that we're going to create, the personal access token classic. And next, we're going to talk about Crossplane. So first, before we do that, let's jump into GitHub Actions and put in some secrets. I'm now back in my GitHub repo, and here is where we're going to create the GitHub Actions variables or secrets. So go to settings and under secrets and variables, select actions. So now I don't have any secrets or variables. I'm going to go ahead and create some repository secrets. So new repository secret. And I'm going to go in one by one and fill this information out. Okay, so I filled out all the secrets that I mentioned before. All of them are right here. Good to go. Now let's move on, continue with our build here. Crossplane secrets for clouds. So the next step now is to prepare our AWS credentials. Again, we saw before, so we can put these in this file called under Crossplane. So AWS credentials example here. So what we want to do is probably just copy it and then change the name to awscredentials.conf. And then we're going to fill out our access key ID and secret access key that we got from before right here. Once again, these are temporary. They only last for 3 hours in my Tech and AIDS Academy Premium. No worries for you to see them here. Okay, so that's good to go. Now let's go back and see what else. Create the secret in Kubernetes. So we want to create the secret right here based on that config. Okay, so I'm running in workspace because we're thinking that we're going to do this in the workspace itself, in the Codespace workspace. So the file is not quite correct. So let's go into our proper directory, which is Crossplane right here. And if I run this command again, but this time from file, like that. Perfect. My secret is created. I can verify the secret is created with this command. Perfect. So this is going to allow Crossplane to access AWS to create the EKS cluster. So we could create the EKS cluster directly as shown, but of course we want to use Backstage. So we're going to skip this section. Just know that you can just run these commands and create an EKS cluster directly with Crossplane. But again, we want to use Backstage because this is our own little internal developer platform. First off, to install Backstage, make sure that we're in the Backstage folder. So let's go there. Okay, we need some secrets in here. So if you go to Backstage and my Backstage app, and down here we have the secret example.sh, and I have a bunch of secrets that I need to fill. So just like we did before, let's copy that and change the name to secrets.sh. That's what we need. And then go ahead and fill out this information to what you need. And I'll explain these a little bit. So GitHub token is, again, similar to what we did before. You can probably just use the same GitHub token. And then the auth GitHub client ID and secret to allow authentication with GitHub inside of Backstage. Kubernetes config CA data and SA token. This just allows you to access the current or give access to a Kubernetes cluster in Backstage. If you want to work with Google and tie in to GCP, you can use this. Authenticate Google Client ID and secret. Once again, just like we can create GitHub authentication to authenticate to Backstage, you can do the same thing with Google. And then ArgoCD auth token. This is the one we talked about before that we generated a while ago. So if I show you here earlier on in the demo, we saved it here somewhere. There, ArgoCD token. So this is important to allow Backstage to access ArgoCD and use the ArgoCD plugin inside of Backstage to give us feedback when the vCluster is ready. And then the last three, you can make up these passwords yourself. Just give an admin password, user password, or application password for Backstage itself. Okay, so I'm going to fill this out and we'll continue. Okay, the secrets file is all ready. We're going to continue now to create our secret. Let's run this particular script. And I believe the script might actually need to be adjusted because we're not running inside of the... Actually, let's run it and see. Yeah, so we do need to adjust it because it's referencing files with an absolute path that will give us some trouble here. Let's assume we're in the Backstage folder. Let's remove these. And what this does, it's good to go through it real quick. It's going to create, or it's going to look at the input file, which is the secrets.sh, and is going to give us a my backstage secrets.yaml file. And basically this will be used to create the secret that we're going to use with Backstage. Okay. So now that we've adjusted this a little bit, we can go ahead and run that again. Secrets have been written to this file, my backstage, and I also have it as in the .ignore file for Git, so it will not show up if you decide to push this to Git. The next step is to actually apply it. So if we go ahead and run kubectl apply -f and my backstage app, and then my backstage secrets.yaml. So that should get applied for us. And this comment here, if you want to create GCP or want to access GCP by your Google credential files, put your Google credentials files in this location. Then you can create this secret like that. And you can uncomment these sections here in the values file for the Helm chart that's going to install Backstage. We're not doing that right now, but in a future video, we'll probably use GKE. So we'll go to that and do that. But for now, let's continue on. And now we're ready to run our Helm command to install Backstage. So we're going to run this, but again, adjust our location because we are not inside of Codespace directly. So this should do it. All right, let's make sure we are in Kubernetes, and let's go into Backstage namespace. And let's watch our pods until they are ready to go. And this will take us about a minute or 2 minutes or so. We see our Postgres database is not ready yet. This is going to fail. This is our Backstage actual container. It needs to wait until the database is ready. So don't be alarmed if you see this error. Just give it some time. Once the database is up and running, this will be good to go. So Backstage is up and running. Woohoo! Let's get out of here. And now let's take a look at the UI. So we're going to port forward Backstage on port 7007. We can open this in our browser. And here we go. We got Backstage running, looking great. If we go down to create here, you can see the templates that we have available. And very soon, we're actually going to create our own template. We have a template already created for us, but we need to make some adjustments to make it work with our forked repo. So if you go under Backstage templates here, you'll see that we need to make this update in the template file. So the templates are in this directory. If you go under Backstage, my Backstage app, packages backend, and then under backend, we have templates here, and then we're interested in this EKS Cluster Crossplane and this template file. And you can see here at the bottom, first of all, really quickly, this is how you define a template. And I have a whole video on Backstage templates you can take a look at. But it's made up of multiple steps. We'll see that GitHub Actions is one of those steps. And there's a repo URL where it's telling, where Backstage needs to know where to send, where the GitHub repo exists so that the action can get created. So in our case, we need to update the repo. The repo is not platform engineering. It's different. So let's pick that up from GitHub. So let's see here. Our repo is called vCluster demos. So vCluster demos, and the owner is Tekkening. We also need to change this branch to master from main to master, and that should do it. Now we just need to update repo. We're going to commit this. And push the changes. Now, what we need to do is register this now. And to register, we need to go to our actual GitHub here and get the actual template. And the template is under Backstage and my Backstage app, packages, backend, templates. And I'm interested in the EKS Cluster Crossplane template, this one here that we were just changing or modifying inside of our Visual Studio Code. So I'm going to copy that link at the top and go back to Backstage. And under create here, we can register an existing component. And now we can put in our URL, analyze that, and import. And that's it. Now let's go ahead and create. Here it is, EKS Cluster with Crossplane. Let's go ahead and run this template. And let's fill the form here for our template. Let's call this EKS Cluster Demo 1. That's the name of the repo. Cluster name, EKS host cluster, small size for the node size, version 129 for Kubernetes version, and then minimum node count is 1. Let's review that. Let's go ahead and create that. And here we're going through the steps of the template. So fetching the base, publishing our new GitHub repo that we just created, and then triggering the GitHub action. So let's take a look at the GitHub action by going to GitHub and going under the Actions tab. And here's our action that completed. And you can further look at the different steps. So checking out the code, installing ArgoCD, logging into ArgoCD, registering the GitHub repo in ArgoCD, and deploying a cluster with ArgoCD. So that went ahead and created an application in ArgoCD. So if we go here, we see the application is already running and it's synced and healthy, which is all a really good sign. And what this means is that we are now running Crossplane, and Crossplane is creating an EKS cluster. And once the EKS cluster is complete, we'll see a secret for the kubeconfig for EKS that will get generated. So now we can take a look at the Crossplane piece, and a shout out to Victor from Upbound. I took a lot of his code here in terms of getting EKS up and running. So here's a cluster claim where we are creating a cluster. We can create a cluster. And this cluster claim really is embedded in the actual Backstage template. So if you notice in the template under Backstage, packages, backend, templates, and EKS Cluster Crossplane, if you look under content, there's an XR claim. And this actually is taking on values that are dependent on what we put in the Backstage template. So the cluster name will show up here, the node size, the minimum node count, and the version, and then writing the connection secret to reference with a cluster name. So this is the secret that will give us the kubeconfig into EKS. So this cluster claim basically calls on a composition, and this composition you can take some time to look at under compositions here. Again, shout out to Victor for building this. So you can see here, this composition is quite lengthy. And this is EKS. If I jump into GKE, you can see there's a composition for GKE. and there's one for AKS as well. So we can really use this composition, and with a different claim for each hyperscaler, we can generate these clusters. Okay. So now that we see how Crossplane works and how it's integrated with Backstage, I can run kubectl get namespaces, and we'll see very quickly, you'll see the different namespaces, of course, but here's the EKS host cluster namespace that got generated by ArgoCD. So if I get into that namespace, and if I run, I want to show you the cluster claim. So if I run kubectl get cluster claim, I see that there's the cluster claim is running right now, and it's not fully ready yet, of course, because there's multiple different things that depend on each other. So we just need to be patient. This takes about half an hour to generate the EKS cluster. And again, this is dependent on AWS and nothing else. So we can also run the command kubectl get managed, which is a shortcut to show us all the managed resources that the composite resource is creating. And here we go. These are all the managed resources that are getting created by Crossplane. So you can see things like a route here, internet gateway. And when it says ready is true, that means it's already been created. And in just a minute, we'll take a look at the AWS console itself. The routing table associations, a bunch of them, a route table, security groups, subnets, VPC. And notice this add-on EKS is not yet ready. So this is still being created. The cluster auth is not synced yet or ready. So that's going to get created at the end to get our kube config. We got our cluster itself is also not ready. Of course, the node group is dependent on the cluster, so that's not ready. And a few other things here, role policy attachment and so on. And so basically this is showing you how Crossplane is working behind the scenes to get our environment ready for us. We have finally created the EKS cluster, and you can see in ArgoCD here the secret that got created, which really hosts or contains the kube config for us to access that EKS cluster. So let's go ahead and access this EKS cluster. Let's go back to our documentation here, and it shows you here how to access this cluster using that secret. Okay, so let's see our secret here that got created. kubectl get secret. And here we go. I have a command for us to show this secret and save it in a kubeconfig file. So let's copy this command. We're just going to have to change the name of the secret because this is a different name, which is EKS host cluster. Hit enter. That will get saved in a file called EKS kubeconfig.yaml. So let's export that into our kubeconfig environment variable. And from here, I can see that my kubectx context has changed to EKS host cluster. So I can now run kubectl get nodes. And I only have one node, right, in EKS. And also kubectl get namespaces. I have some namespaces that already got created by Crossplane, like dev and production. Again, this is configurable if you wish. So let's first, before we register this in ArgoCD, I'd like to show you, if you don't believe me, that this is actually in EKS. I'll bring in the console here, the AWS console. So let's refresh EKS clusters here. And here we have our EKS host cluster active version 129. And if you go in here, you can see the server endpoint. And now let's register our new cluster in ArgoCD. So from that point forward, our developers can request new vClusters inside the host EKS cluster. So let's do that by running this command, but we got to substitute our cluster context here with the name of the cluster context, which is EKS host cluster. And we can give this a name. So we'll call this our EKS host cluster. Actually, same name is fine. And just say yes. And this will create a service account, cluster role binding. And that should now be added into our ArgoCD instance here. So if you go into ArgoCD, go into settings and go under clusters, and you can see EKS host cluster has been added successfully. Don't worry about this unknown status. It will turn into successful once we start working with this cluster. Okay, let's continue with our documentation here. And now we're setting up the vClusters, or getting ready for vCluster to get created for our devs. And we need to add this target domain. And as platform engineers, we're going to add this target domain to our GitHub Actions secrets, again, to be done once. The target domain is really the host name of the load balancer that Traffic's ingress route TCP creates, so you can access those vClusters remotely. To do that, you need to run this command, kubectl get service traffic. So let's run this command inside of our EKS cluster, our new EKS host cluster. So let's grab this host name now. And now we just need to add this to our GitHub Actions secret. So let's do that right now. Go under settings and under secrets and variables, actions, and our target domain here. Here's our load balancer. Update that. Moving on, now we need to add the EKS clusters endpoint to the Backstage template so that Backstage, when you're creating a vCluster, knows which host cluster to use for the vClusters. So in this case, it would be the EKS host cluster. So to do that, you can find that inside of ArgoCD. Let's go ahead and go to ArgoCD. And really, if I'm in the application, go to settings, clusters, and EKS host cluster right here. This is the URL I need. So click in here and copy that. So that's my server URL. And now if we go back to our templates folder, which is under Backstage, my Backstage app, packages, backend, templates. And now we're looking at the vCluster, and you want to update the template.yaml. And specifically, if you scroll down to the Kubernetes host cluster URL for Argo, this enum here is basically going to force our developers to use this particular EKS cluster. So let's delete this one that was there from before and put in our new server URL for our EKS cluster here. You also want to make sure that your GitHub Actions step contains the correct workflow name, which should be the same if you fork this repo. But then the repo URL will be different in your case. And also the branch or tag name should be master. So this we did before in our EKS cluster demo or EKS cluster template. So I can just grab this value here for my repo URL and put it in here. You'll also remember to update your host cluster name with the new cluster that we're using. In this case, EKS host cluster is the name of that EKS cluster that we created in AWS. And with that, we can now push our code. Let's update. Let's say we updated our endpoint for server, URL endpoint for server, and let's commit that. And let's push that change. And now we should be ready to register this template and start using it. So you can see, again, more instructions here in the documentation, where now we're registering our new vCluster template in Backstage. So simply go back to the code and just show you where to find that template. Go to Backstage, my Backstage app, packages, backend, templates, and vCluster is our new template, template.yaml. Copy the URL from the top there. Now let's go back to Backstage and go to create, register an existing component. Let's paste the URL, analyze, import, and now we're ready to go. Now I'm in the persona of a developer. So my platform engineering team has created this nice new virtual cluster template for me. As a developer, I'm going to go ahead and choose this template, put in my owner name, repository, let's say app, let's call it team A app 1. Cluster name, do the same, team A, 1. And as you can see here, we only have one option. This is our host EKS cluster. So we'll select that, click review, click create, and that will go ahead and publish this new repo for us, trigger a GitHub action, and register this component. So we can do a couple things. We can look at our repository. Here's a repository ready to go. And just for the sake of argument, I put here a main Go app that you can have as part of this repo, actually. I have another video showing you how to deploy this also in the EKS cluster and have some deployments that you can use inside of Kubernetes. But for the sake of this demo, we're going to just skip over that. And if we go back here, you can open this in catalog, and now you can see that at the bottom here, ArgoCD, you see nothing available here. In just a few minutes, once Argo has created this vCluster, we're going to see that this is ready to go. So as a developer, once again, I just need to view that my cluster is ready, and then I can access the kubeconfig of this cluster straight from Achilles, which I would have access to as a developer. So we're presenting, or we're sending the actual credentials into the cluster in a secure method into Achilles. So let's take a look at ArgoCD and see what's going on. I see here my team A app 1 is syncing, or I think it's already synced. So that looks pretty cool. Let's go back to Backstage and refresh this. And you can see here at the bottom that we are synced and the health status is healthy. So again, as a developer, I can see this and I can jump into my Achilles dashboard and get my kubeconfig, which I'll do in just a minute. But I wanted to show you here what we can see from ArgoCD, the destination server, the repo path, repo URL, the destination namespace, status is synced, and so on. So let's now just go ahead and get our kubeconfig. So click this link, will take us to Achilles, and let's log in. And under vClusters, once again, this will be available to your developers. Ahead of time, you have a folder, for example, in Achilles with the different teams, and every team has access to, let's say, a kubeconfig for their cluster. Let's reveal the value here. There we go. Here's our kubeconfig. Let's copy that and go back to our Visual Studio Code. And from here, we're going to access the new vCluster. So let's use this variable here, encoded kubeconfig equals, and then paste our kubeconfig in base 64. And then let's decode it with this command. And then let's go ahead and export our kubeconfig environment variable to access cluster. Now we can run kubectl get namespaces, and now I see my new virtual cluster. I can also run kubectl get nodes, and I can see that I have one node here. Congratulations. Basically, you've created an internal developer platform, you've used vClusters, and now you can go ahead and use those vClusters in your environment with your developers. You can go ahead and provide that template through Backstage, and it becomes a vending machine of vClusters for your developers. Thanks for watching.